Yo, what's up everyone? It's Pointer Coding back again with another video. And today, we're switching things up a bit. We're diving deep into the world of computer science and engineering, breaking down some essential tech terms that every student, every aspiring tech wizard needs to know. Whether you're just starting your coding journey, trying to ace those exams, or just want to sound super tech savvy in your next class, this video is your cheat sheet. We're talking about those fundamental concepts, those buzzwords that get thrown around all the time, from algorithm to YAML. So grab your notebooks, put on your learning hats, because we're about to level up your tech vocabulary. Let's get right into it. First up, we have algorithm. Now, this might sound intimidating, but it's really not that complicated. Imagine you have a problem to solve, like sorting a bunch of numbers from smallest to largest. An algorithm is simply a step-by-step procedure for solving that problem, a set of instructions that your computer can follow to get the job done. Think of it like a recipe for your code. Just like a recipe tells you exactly what ingredients to use and how to combine them to bake a cake, an algorithm guides your computer on how to process data and achieve a desired outcome. From searching the web to recommending your next favorite song, algorithms are the backbone of how software works. Next, let's talk about arrays. Now, imagine you have a bunch of items, like a list of your favorite movies. An array is like a digital container that holds a fixed size collection of those items, and they're all neatly organized one after the other. The cool thing about arrays is that you can access each item directly by its position in the list, kind of like numbered shelves in a library. So if you want to watch the third movie on your list, you can just tell your computer to grab the item at position number 3 in the array. Arrays are super useful for managing collections of data, and they pop up everywhere in programming. Now this one's a hot topic, artificial intelligence, or AI for short. We've all heard about it, seen it in movies, but what exactly is it? In a nutshell, AI is all about making machines smart, like really smart. It's about creating computer systems that can learn from experience, adapt to new information, and perform tasks that typically require human intelligence. Think self-driving cars, virtual assistants like Siri or Alexa, even those personalized recommendations you get on your favorite streaming platforms. AI is revolutionizing the tech world, and it's only getting smarter. Alright, let's talk big data. Now, imagine you have a gigantic mountain of information, like all the posts on social media, all the financial transactions happening every second, all the sensor data from devices around the world. That's big data. Massive, complex data sets that are too large and too unruly for traditional data processing methods to handle. We're talking about extracting meaningful insights from this data deluge, identifying trends, making predictions, and uncovering hidden patterns. It's like finding needles in a digital haystack, but on an astronomical scale. Now, let's get down to the basics, the language of computers' binary. At its core, binary is a number system that uses only 2 digits, 0 and 1. That's it. It's like a secret code that computers use to represent all information, from the text you're reading right now to the videos you watch online. Think of it like a light switch. It's either on 1 or off 0. Every image, every sound, every piece of data is ultimately just a series of zeros and ones. It's the foundation of how computers store and process information. Okay, let's face it, we've all been there. You're coding away, feeling like a tech wizard, and then bam, you hit a wall, a bug. Bugs are those pesky errors, flaws, or faults in your code that cause your program to crash, behave unexpectedly, or produce incorrect results. They're like little gremlins in your software, and they can be frustrating to track down and fix. But hey, debugging is part of the coding journey, and finding those bugs is like solving a puzzle. It's all part of the fun, right? Let's talk about cache. Now imagine your computer's memory as a big library, and the information you need is stored in books on different shelves. Cache is like having a small bookshelf right next to your desk where you keep the books you use most often. It's a smaller, faster memory that stores copies of frequently accessed data from the main memory, making data retrieval much quicker. So, instead of searching through the entire library every time you need something, you can just grab it from your handy cache. Cloud computing. It's everywhere these days, but what exactly is it? Imagine a world where you can access all your files, applications, and computing power from anywhere, at any time, without being tethered to a physical device. That's the power of the cloud. Instead of storing everything locally on your computer, cloud computing allows you to store and access data and software over the internet, kind of like renting space on a remote server farm. It's like having a virtual office in the sky, accessible from any device with an internet connection. Alright, let's talk about compilers. Now remember how we talked about binary being the language of computers? Well, humans don't typically write code in binary. It would be a nightmare. That's where compilers come in. A compiler is like a translator between you and the computer. It takes the code you've written in a high-level programming language like Python or Java and converts it into machine code, those zeros and ones that the computer can understand and execute. It's the magic that makes your code work. In today's digital age, cybersecurity is more important than ever. Think of it as the digital shield that protects our data, our privacy, and our digital lives from those who would seek to exploit it. From hackers trying to steal your personal information to malware designed to disrupt systems, cybersecurity encompasses all the measures we take to defend ourselves in the digital realm. It's about building secure systems, implementing strong passwords, being aware of phishing scams, and staying one step ahead of the bad guys. In a world increasingly reliant on technology, cybersecurity is everyone's responsibility. Let's talk about databases, the digital warehouses of information. Imagine a massive, organized library where every book, every document, every piece of data is meticulously categorized and stored. That's essentially what a database is. It's a structured collection of data, typically stored and accessed electronically, allowing us to retrieve and manipulate information quickly and efficiently. From customer records to inventory management, social media interactions to financial transactions, databases are the backbone of countless applications and websites. We've all been there. You're coding away and suddenly your program crashes. Time to put on your detective hat and start debugging. It's the process of finding and fixing those pesky bugs, those errors that are causing your code to go haywire. Think of it as code surgery, carefully examining each line, looking for the source of the problem. It can be frustrating at times, but there's a certain satisfaction in finally squashing that bug and getting your code to run smoothly. Let's talk about encryption, the art of scrambling information to keep it secret. In a world where data is constantly flowing through the digital ether, encryption is like putting your message in a lockbox that only the intended recipient has the key to open. It's about transforming data into an unreadable format, making it nearly impossible for unauthorized individuals to make sense of it, even if they intercept it. From online banking to secure messaging apps, encryption is essential for protecting our privacy and sensitive information in the digital age. In the world of software development, frameworks are like pre-built structures, providing a foundation for building applications. Think of it as a set of tools, libraries, and guidelines that streamline the development process, saving you time and effort. It's like having a blueprint for your code, providing a consistent structure and best practices to follow. Frameworks can help you build applications faster, more efficiently, and with greater consistency. Let's talk about functions, those reusable blocks of code that perform specific tasks. Think of them as mini-programs within your main program, each designed to do one thing really well. Functions help you break down your code into smaller, more manageable chunks, making it easier to read, understand, and maintain. Just like a good chef has a recipe for each dish, a good programmer has a function for each task. For all you aspiring software developers out there, Git is your new best friend. Imagine you're working on a team project, and everyone needs to make changes to the same document. Git is like a magical version control system that keeps track of every change, every edit, every version of your code. It's like having a time machine for your project, allowing you to revert back to previous versions, track down who made what changes, and collaborate seamlessly with others. All right, let's talk about IDEs, integrated development environments. Now imagine you're a chef, and you have a fully equipped kitchen with all the tools and appliances you need to whip up a culinary masterpiece. That's what an IDE is for programmers. a comprehensive software suite that provides everything you need to write, test, debug, and deploy your code. From code editors with syntax highlighting to debuggers that help you find errors, IDEs streamline the development process and make coding a more efficient and enjoyable experience. In the vast interconnected world of the internet, every device needs a unique identifier, a digital address. That's where IP addresses come in. Think of it as your device's home address in the digital world. It's a string of numbers that identifies each computer or device connected to a network, allowing them to communicate with each other. Just like you need a postal address to send and receive mail, your device needs an IP address to send and receive data over the internet. Alright, let's dive deeper into the world of AI with machine learning. This is where things get really interesting. Machine learning is all about teaching computers to learn from data without being explicitly programmed. It's like giving a computer a huge data set and saying, hey, find some patterns, make some predictions, and surprise me with what you can do. From image recognition to spam filtering, machine learning is powering some of the most innovative technologies today. Let's talk about object-oriented programming, or OOP for short. A widely used programming paradigm that's all about organizing code into reusable units called objects. Think of objects as real-world entities like cars, houses, or even people. Each object has its own properties, like color, size, or name, and methods, like drive, open door, or speak. OOP allows you to model complex systems in a more intuitive and organized way, making your code more modular, reusable, and easier to maintain. Alright, let's talk about the unsung hero of your computer, the operating system, or OS for short. This is the software that acts as the intermediary between you and your computer's hardware. Think of it as the conductor of an orchestra, managing all the different components and making sure everything runs smoothly. From managing files and running applications to handling input and output devices, the OS is the backbone of your computer system. Whether it's Windows, macOS, Linux, or Android, the OS is what makes your computer usable. Protocol. In the world of technology, protocols are like the rules of the road, ensuring that devices can communicate with each other effectively. They're a set of standards or procedures that govern how data is exchanged between devices, kind of like a common language they all understand. From HTTP for web browsing to TCP/IP for internet communication, protocols are essential for ensuring seamless connectivity and data transfer in the digital realm. Let's talk about queues, a data structure that follows a strict first in, first out, FIFO principle. Think of it like a line at a ticket booth. The first person in line is the first person to get served. Queues are used in programming to manage tasks, requests, or data in a specific order, ensuring that everything is processed in a fair and sequential manner. Now, this one's a bit of a mind-bender recursion. It's the process of a function calling itself within its own definition. Think of it like a set of Russian nesting dolls where each doll contains a smaller version of itself. Recursion is a powerful technique in programming, allowing you to solve complex problems by breaking them down into smaller, self-similar subproblems. In the world of software development, a repository is like a central hub, a single source of truth for your codebase. Think of it as a master folder that stores all the files, folders, and history of your project. Repositories are essential for version control, allowing developers to track changes, collaborate on code, and revert back to previous versions if needed. Platforms like GitHub and GitLab provide cloud-based repositories for easy collaboration and code sharing. Let's talk about runtime, the period during which a program is up and running, executing its instructions. Think of it as the showtime for your code, the moment it comes to life and does its thing. During runtime, the computer's processor is busy fetching instructions, processing data, and producing output, all according to your program's logic. In the world of technology, scalability is the ability of a system to handle growth gracefully, to adapt to increasing demands without breaking a sweat. Think of it as a rubber band. It can stretch to accommodate more data, more users, more traffic, without losing its elasticity. Scalability is crucial for applications and systems that need to grow and evolve over time, ensuring that they can handle the demands of a growing user base or increasing workloads. Let's talk about SQL, Structured Query Language, the language of databases. If you want to interact with databases, retrieve data, manipulate data, or just have a chat with your data, SQL is the language you need to speak. It's a standardized language for managing relational databases, allowing you to perform all sorts of operations on data, from simple queries to complex data manipulations. Let's talk about stacks, another data structure, but this one follows a last-in, first-out LIFO principle. Think of it like a stack of plates. The last plate you put on top is the first one you take off. Stacks are used in programming for managing function calls, tracking data during program execution, and various other tasks where you need a LIFO data management approach. Let's talk about threads, those lightweight processes that allow programs to multitask like a pro. Think of threads as separate workers within a program, each capable of executing its own set of instructions concurrently. Threads allow programs to perform multiple tasks simultaneously, improving performance and responsiveness, especially in applications that deal with user interactions, background processes, or parallel computations. You know those web addresses you type into your browser every day? Those are called URLs, Uniform Resource Locators. They're like the GPS coordinates of the web, pointing your browser to the exact location of a web page, image, video, or any other resource on the internet. URLs consist of different parts like the protocol, HTTP or HTTPS, the domain name like Google. Let's talk about virtual machines or VMs, those software-based emulations of physical computers. Think of it as having multiple computers running inside your actual computer, each with its own operating system and applications. VMs are used for a variety of purposes, from software development and testing to running different operating systems on a single machine, providing isolation, flexibility, and resource optimization. Let's talk about web APIs, application programming interfaces for the web. APIs are like messengers that allow different software systems to talk to each other, to exchange data and functionality. Think of it as ordering food online. You interact with the restaurant's website or app, which sends a request to their system to process your order. Web APIs enable this seamless communication between different applications, making it possible for software to interact and share data. Let's talk about XML, Extensible Markup Language, a way to structure data in a human-readable and machine-readable format. Think of it as a set of rules for organizing and tagging data, making it easy to transport, store, and interpret. XML is widely used for web feeds, configuration files, and data exchange between different systems. Last but not least, let's talk about YAML, a human-friendly data serialization language. YAML is all about readability, using indentation and a simple syntax to represent data in a clear and concise way. It's commonly used for configuration files, data exchange, and as a more human-readable alternative to JSON. YAML's simplicity and readability make it a favorite among developers for various tasks. And there you have it. We've just broken down 35 essential tech terms that every CSE student should know. Now you're well on your way to becoming fluent in the language of tech. Hopefully this video has demystified some of these concepts, giving you a solid foundation for your future studies or that next tech conversation. If you found this video helpful, make sure to give it a big thumbs up, hit that subscribe button for more tech content, and don't forget to ring that bell so you don't miss any future uploads. As always, thanks for watching. Until next time, keep coding, keep learning, and keep pushing the boundaries of what's possible in the world of tech. Peace out.